So we've got an interesting lecture this morning on debugging .NET Core web applications and troubleshooting. And I always like teaching, I always enjoy teaching the debugging chapters on any topic because it really begins to separate, developers in their ability levels, those that can troubleshoot problems and fix problems versus those that cannot or struggle to. You become a much better developer when you learn these tools. Like, there's no questions about it. And so, like, today, when I'm working with you guys so often, because ChatGPT is so ubiquitous, it's like, hey, let me just throw it in ChatGPT and see if I can get an answer. But as we've kind of discussed the weaknesses around ChatGPT, and just off the top, that how often it gets the answer blatantly wrong. But then additionally, its knowledge base is I think up until, originally it was 3 or 4 years old. Like, the data that seeded ChatGPT was just old. And so my point is, you guys often want to go to ChatGPT as a first answer, but you shouldn't. Like, frankly, that's not where you should go first. You should take a couple other series of steps that I'm going to recommend in here. Okay? And I also like kind of telling a story about troubleshooting that is very personal to me, and it was a learning experience for me. And I think it's valuable to my students, again, this class or any class. So maybe you've heard this story before, so forgive me if I'm repeating myself. But it was a lesson for me. And so, do you guys know that my personal experience out of Rankin, I got a job when I was in my third semester. Okay, so this is personal to me. You may not care, but in my third semester, I started working about 20 hours a week. And then I went full-time upon graduation. So I graduated, I'm 20 years old at this point, and I'm working my first big boy job. I'm working 40 hours a week, and I'm making $10 an hour. Not that the money matters, but I wasn't making big money. Okay? And at that time, I was not a developer. At that time, I was working on I was just a general technician. I was like an IT technician, fixing computers, working on servers and networks and things of that nature. And the part that is embarrassing for me to tell, that I have a hard time telling, is I actually got fired from my first job. Did I tell you guys this before? Yeah. So some people say, yeah, I remember that. Some people say, no, I don't. So maybe I told this to you in a prior lecture. Does anyone remember why I got fired? Yeah. I was raised in the educational system in America where as soon as I had a problem in school, we are trained pretty quickly to raise your hand and get help from the teacher. And I was good at asking my teacher for help. And my teacher would provide guidance, and I'd get the answer, and generally that led to good grades. Like, my grades were good always in school, A's and B's. I was happy with my grades. But then I took that same attitude, which was, if I'm stuck, I immediately pretty much asked for help. And what happened was I would ask my coworkers for help. Instead of asking, like, the teacher, there was no teacher, I would ask my coworkers for help. And eventually, I was just asking my coworkers for help all the time, drawing them off of what they're working on. And now they're working on my problems, right? So essentially, two people are solving one problem at that point. And my boss kind of pulled me aside and he goes, Evan, you're kind of distracting your coworkers from their problems, and and they're having to fix your problems all the time. And we got to get you to where you're actually solving problems yourself. Because if there's anything about this industry is that new problems are every day. Okay? Like this whole thing of school and like I'm going to show you something and then you're going to test on it like you've seen it before. Like that's not exactly the real world. The real world is you're going to have some of that repeat business, if you will. But you're going to see new problems every day. And you're going to have to learn to troubleshoot and fix these problems yourself. So I never did that. Like I never took my boss's advice, and he ended up, like it was a small business, he ended up having to let me go. I was heartbroken. I went home to my mother and I cried. I literally had lunch with my mom at Applebee's, and I remember being in tears. I'm 20 years old. I'm in tears at Applebee's because, Mommy, I got fired from my first big boy job. Okay, it was a humbling experience. Here's a lesson that I learned. My next job, I had one attitude switch. I had one mental switch in my head that I changed that led to completely different results. The mental switch that I flipped in my brain was that every time I see a problem that I've never seen before, I'm going to spend X minutes. I think it was 15 to 30 minutes from what I remember. I'm going to spend between 15 and 30 minutes trying to solve it myself before I ask my coworker, before I ask my supervisor for help. Okay? And I literally got the same job in Illinois because I was working in Missouri. The job I got fired from was in Missouri. It was closer to my house. It was like a 5-minute drive from my house. I got paid $15 an hour instead of $10 an hour. It was the same exact job. And I went from being so bad that I got fired, just that one switch, to I got promotions. I got praised by my boss. You're such a good worker. You're doing great work. Like that little switch in my brain, like, you know what? I'm going to try and solve these problems instead of letting someone else solve them. It made all the difference in the world. And then you fast forward that into my career. Now I'm a teacher. And if you know anything about computers, you know, I can code something the same way, and all of you can code something the same way. It'll work 99 out of 100 times, but one time out of 100, you're going to see a problem you've never seen before. And so now as a teacher, I still see problems I've never solved all before, and guess who has to fix it? You know, the student typically isn't going to fix it. It's on the teacher, right? And so I certainly don't have all the answers, but I like to believe that I can come to find the answers through troubleshooting, and that makes me at least a capable teacher if I know how to get to a solution. Okay, that's my belief. Okay, and so now you have to reflect on that as yourself. Like you guys are in 4th semester, you guys are getting ready to graduate. I will tell you in this class, it's a spectrum of, do I ask too many questions? Some people will say, oh, you can't ask too many questions. I don't agree with that. I got fired from asking too many questions. Okay? So there are people in this class, yeah, you probably ask too many questions. You don't put enough effort in yourself. I'll tell that, you know, some people in here are like that. There's some people on this class that are on the other end of the spectrum. They don't ask a question. They're just going to fail the assignment. They're going to fail. They're not going to ask any questions. That's a problem too, right? You should have a line in your head, like, I'm going to try and fix this for so many minutes. Don't get stuck in the mud and not go anywhere, right? You should have, I think, a balance of, you know, I'm not going to ask a question the first second it comes into my head, and I'm also not going to ignore the question or get stuck in the mud and not find the solution from my teacher. And so I think that's the healthy practice in school. So as you guys are getting ready to graduate, you know, think, where are you on that spectrum? Okay, am I asking too many questions? If you are asking too many questions, I've been there myself. Okay, am I not asking enough questions and therefore I'm not getting the things done that I need to get done? Or where do I fall? Okay, So all that just to say, I like this chapter because it's personal to me and it helps you teach. These are the tools that can help you solve the problems that we'll all need to be able to solve here in about, 80 days or so, ideally when we're graduating, applying for jobs, and starting to land some jobs. Okay, now I'm going to say off the bat, the most useful thing if I'm looking at all these objectives, okay, changing the browser, hot reload, debugging features of the browsers, exceptions in the browser, 4 and 5, the exception helper, breakpoints, stepping into locals and watch, immediates, and trace points. The most valuable thing here, the most valuable thing in this chapter is a breakpoint. Okay? By far, understanding breakpoints, getting familiar with and getting comfortable with breakpoints. Okay? You've seen breakpoints before, but it is often intimidating. How do breakpoints work? What am I looking at? Breakpoints, in my opinion, the most valuable thing in this chapter. There are other things that we will cover. Okay? But I have Visual Studio pulled up here. Okay? And we're going to start with, because it's the most important thing, I'm going to go a little bit in whatever order I feel like and talk about breakpoints. So I've got kind of the MVC app here that's Sports Pro. I've got my models kind of here. I've got my context. Okay, so these are all my models. I'm going to close all tabs. And I've got my controllers. Okay. And so I'll just open up, for example, my technician controller. All right. So breakpoints are the most important thing. To insert a breakpoint, number one, where do you even insert a breakpoint? Okay. It's in this margin over here, in this gray margin. You can see the gray dot, and you want to put it on an executable line of code. This is broken across multiple lines, but this is essentially one executable line of code. What is a breakpoint? A breakpoint will stop your application at a certain point of execution. So the application will run up until a certain point, which is the breakpoint, and then it will stop executing at that point and then let you step through your code line by line. And so there's really not a perfect place for a breakpoint. But this is fine. This is when you're listing all of your technicians, right? And you can insert multiple breakpoints. I will say that beginners tend to put these things out here like Skittles. They just throw them everywhere. I'll show you when it makes sense to have multiple breakpoints. But when you're beginning troubleshooting, I just like to have one. Because, well, this is the one place I want my code to stop. Now, you realize there's two different start buttons, two different play buttons here. Okay, there's the filled in play button, and then there's the hollow one. So as I'm hovering my mouse, start without debugging is just that. You're not going to see debugging tools. This actually runs it faster. So if I'm not trying to debug my application, I'm just trying to run it, I'm going to start without debugging. But if I want to get into a debug mode, then you're going to click on this play button. Okay, now this play button will hit your breakpoint. Okay, realize the other one will not hit your breakpoint. So if you have a bunch of breakpoints and you don't want to hit them, well then you start without debugging. It generally starts faster, and if you're not trying to troubleshoot, then you're just trying to, run the thing, then you start without debugging. Otherwise, we're going to start with debugging. It'll start it a little bit slower. Okay, and the page will launch. Now, I have a default browser selected here, and notice this is even taking a little bit of time to boot up. And you're going to notice already the windows are changing, so people get intimidated, like, what are these windows? I see my RAM utilization. I see all this stuff going on. What is going on? It's a lot to look at. Okay, so I want to try and kind of hone in on the important pieces here. These diagnostic tools, Visual Studio tends to be a memory hog, and I've got a lot of RAM on this computer, so that's kind of crazy to me just looking at that. But let's go back. I'm in Google Chrome. I didn't hit my breakpoint yet, right? Well, why? Because I'm not on the technicians page. Of course, if I go to my technicians list, I go to /technician, that's the technician controller, /list, that's my list action method, that's where I have the breakpoint, right? So when I click this, I should hit my breakpoint. There you see what it looks like to hit a breakpoint. We went from a red dot to a red dot with a yellow arrow pointing at it. Now this is line 15. Line 15 has not yet executed. Okay, so when I'm looking at these different windows, these are different ways to inspect your variables. It's kind of crazy. Autos kind of shows you what's in scope. What's in scope in this particular point of the application execution. Right now we're in the list method. So kind of what variables does the list method know how to work with, and what methods can it work with? And well, one thing it does see is it sees that this text variable, TECHS, text, is currently null. Well, text is null because line 15 has not executed yet, right? We've got a variable that's in scope, but there's nothing in it. It's null. And so these controls right here are your main controls that you need to be familiar with in this breakpoint mode. Okay, here's the difference. Step into will execute line 15. Step into, or F11, this is your best friend in this mode. That's just going to execute one line at a time. Very simple, execute one line at a time. Step over, okay? Well, let's just say that there's a method call. If I'm stepping into one line at a time, and then you're calling a method, the breakpoint will go into that method call. So step into will go into every method that's called, or every property. So notice if I hit step into, it says your step into request resulted in a step over, an automatic step over of a property. So like the technician's property was stepped over. So this behavior can be overridden. Like in other words, if you want to troubleshoot the property, you can go into that property. Do you want to continue being notified when automatic step over happens? Okay, so typically when you step into it, you go into the properties, you go into the method calls. But this little notification said, hey, we're actually gonna automatically step over something. That's what a step over is. A step over says don't go into that line of code, but go over it. In other words, if you trust a method or you trust a property, you don't want to troubleshoot it, you know that it's good, you could step over it. And so, do I want to be notified? No, I'm gonna click no. I don't want that notification. So notice here, it kind of went into my my context class. Now this is interesting because I actually don't want to be in my context class. I'm actually caught off by this, that it's sending me here. But it's a good example of when, hey, I actually don't want to troubleshoot my context class. Let me step out of this. So that's the next control. So step into is normal. Step over is like, I don't want to troubleshoot this method or this property. I'll step over it. But if you do step into something that you like, hey, I don't need to be here, you can step out. Okay? So notice it took me into my name property. So again, I kind of don't want to troubleshoot the name property. It's calling and it's doing the order by. Notice how it's ordering by names. So it's actually doing that order by. So finally I got past line 15. What you'll notice is that there were a couple of step intos that I was troubleshooting. You know, this order by had to order by the technician name, so it went into the name property to sort by the name. But ultimately now my technicians are returned, and I can inspect this essentially array or this collection of technicians. Okay, but these controls right here, step into one line at a time. Step over is like, nope, I don't want to troubleshoot that method. I don't want to troubleshoot that property. I can step over it. And then step out of is like, no, I went down into something. I don't need to be down the call stack that low, so let's go ahead and step out. Okay, and then it returns to the view. It sends that technician to the view, and there we have it. Okay, so these simple tools, all that I want to show you is these commands up here to step into, step over, step out. The autos window, let me hit this one more time. Let me refresh this page. Notice I hit the breakpoint again. Let me hit step over. Notice if I step over it, it didn't go into any of those properties. I just hit step over and it stepped it over all those things. So that's actually quite nice. Autos, locals, again, this is kind of, locals is what's in scope. Autos is in addition to what's in scope. What else what else can you work with? A watch window, this is where you manually add your variables. Like it can be a lot to go through these locals and like find what you're actually looking for, right? So sometimes if you're just like, hey, I'm looking for my variable, I'm looking for my text, TECHX, like I just want to look at this variable. So you can manually add watches. Okay, so autos and locals, again, locals, what's in scope. Autos is, well, what's in scope plus some additional things. I don't spend a lot of time in these two windows. I spend much more time in my watches. Plus, I can hover. Visual Studio lets you hover variables, which is a really nice feature, kind of to inspect your variables as you're going through. Okay. Additionally, for those of you who are like, okay, these are breakpoints. I know breakpoints. That's super easy. This is nothing new. Let's throw in a for loop, and this is going to be just a for loop that I less than 100, and let's just do some silly int total equals 0, total plus equals I. Okay, and we'll do something like that. Now, who wants to step through this for loop 100 times? No. If you've ever, used a breakpoint before and you encounter a for loop, well, let's say you pull 100 results out of your database and you're looping through all your results and you got a problem somewhere in there, but you don't know where. Okay? Check this out. So I'm going to hit my breakpoint. And so that's kind of like the breakpoint 101. But check this out. Here's kind of like the next level of breakpoints. You can actually have conditional breakpoints. And so if I go to technicians and hit my breakpoint. Oh, it probably hit the breakpoint. Okay, there it is. Okay, this would be terrible. Like, let's just say there was a logic error in here and you weren't getting the total that you were expecting. Okay, for whatever reason. But you're like, hey, maybe I only want to troubleshoot this on the last iteration of the loop. I don't want to see the loop go through the whole time, but I just want to, you can right click this and you can add conditions. Okay, and there's a couple of ways of doing this. But when you right click this and add conditions, you could say, oh, okay, when the condition is true, we set I equal to 99. Okay, And that was in the breakpoint settings. I'll show you how to get back to that. But now notice my breakpoint has this little plus here. And that's a really nice way of hitting technicians. And if it kind of is spinning here, now when I hover, let's go, so I'm gonna add, it's it just loaded my technicians. So maybe it's a single equals. So let me conditions I equals 99.
99, the for loop stops anyway.
Well, yeah, maybe it needs to be 98. So I thought it would need to be conditional, so I thought it would need to be double equals. Well, 99 should be less than 100, so it should add 99. But let's just change it to that, and let's just try it again. Go to my technicians. Well, okay. Take my own advice is what this is. All right, what did I say that I didn't follow my own advice? I said you want to put a breakpoint on an executable line of code. Executable lines of code terminate on a semicolon. The reason my breakpoint wasn't being hit is because I was putting it here on the for loop. And I guess technically in that for loop there is a semicolon there, but that's just on the initialization of I equals 0 semicolon. Well, I equals 0, that'll never be 99. That breakpoint was never being hit because 0 is never 99. But if I move my breakpoint into the for loop here, and I put my condition here, I'm really glad that we figured this out. Thank you for pointing out my mistake. Now, conditional breakpoint will be hit. So let me boot it up. Technicians, it's spinning. What that means is that our breakpoint is kind of waiting for us. Normally the window pops up, but I don't know if the window stopped popping up for me. So deal with it, but there you go. The breakpoint was hit, and if we inspect, I is 99. Okay, so that's kind of how to fast forward through a loop, or you don't want to hit a breakpoint all the time. And so you can kind of see here in the breakpoint window here, you can see all the different breakpoints and if there's any conditions that they have. Let's go ahead and stop that from executing. So you get the plus symbol there. Let me take that off. Okay, I'm going to get rid of that breakpoint, add another breakpoint here. And there's an actions. And so maybe every time this actions, maybe every time through the loop, you want to print to the console the total, right? That's called tracing through your code, right? You're tracing your code as it executes, and you're spitting out values here. Show a message in the output window, and so I'll do something like $quotes, or maybe I'll just say it says the value of x, y is x, y. So the syntax for writing to the console looks like just kind of following the syntax that they gave me here. And so I'm just going to try and spit out my total as it goes through. And go to technicians. It's spinning. This is clearly not something that I do all the time. It says log to the output window. So notice the output window is right here. And let me figure out this part. It's been a while since I've done this. Okay, I changed my action. So very simply put, in my actions, I just logged total. Now, I know that was a little choppy example, but I do want you guys to zone in because this is a very common, this is console.log, or in the JavaScript world, we had the debug package, and we would insert traces into our JavaScript to let us troubleshoot while the thing ran. And so what I just did was I inserted a trace that allowed me to, each iteration of the loop, watch the total value in this output window. Okay, and whether you're adding some text along with it or not is not the most super important thing, but I did want to show how to create what's called a trace. Okay, and that helps you kind of through the execution of the program. Now you notice it actually didn't stop. It didn't break the program. It wasn't like a breakpoint normally. It's literally just a trace that can help you debug your variables. Okay, so those are kind of like beginner debugging tools to more intermediate debugging tools, all dealing with breakpoints. Again, the breakpoint window. Let me show now why you might set multiple breakpoints. And so I'm going to put a breakpoint here on my listing of technicians, but let me put another breakpoint on my listing of products. And so everyone zone in for me, hop on my screen share, right? If you're kind of zoning out, let's zone back in a little bit. And I want to show why multiple breakpoints could be useful. And so if I go to my controllers and I go product controller, product controller. And so here when I'm going to list all my products, okay, so now I've got one breakpoint over here and one breakpoint over here. And so I can enter breakpoint mode. And if I look at customers, obviously no breakpoint. If I look at incidents, no breakpoints. If I hit technicians, okay, maybe I troubleshoot something technicians, and technicians is looking fine. So I'll step over, I'll step over, I'll step over. Okay, I don't want to go through this for loop, right? So now I can hit continue. Okay, I'm out of breakpoint mode, and I can click around a little bit again, click around a little bit again. Products, oh, now I'm back in breakpoint mode, right? And I can kind of click around here. So you can hit this continue button, and that's the next thing I want to say. The continue takes you back to normal execution of your software until you hit the next breakpoint. So if you're not really sure, well, maybe my problem's over here, maybe my problem's over there, you can insert multiple breakpoints and then go in of break mode, back out of break mode, back into break mode, back out of break mode. Right? Just by hitting continue, you kind of go back and forth. Okay? So again, these breakpoints, the most useful tools, being familiar with how they work. I bet, even though you guys have seen breakpoints before, I bet you weren't super familiar with that continue button and how it can take you in and out of break modes. Maybe I'm wrong about that, but Okay, so that's that. Okay, how to change a default browser? Don't need to spend a lot of time on this. Under the start with debugging mode, you can change the default here, and to change it more permanently is going to be done in settings. Like to change it on Visual Studio permanently, you're going to have to change your Visual Studio settings. But on a project basis, you can change the individual browser. Why do you need to cross-browser test? Well, you guys already know this. Different browsers respond differently to the same code. Okay, in a perfect world, that we would write one code base that would work across all the browsers. That simply isn't the case. Browsers respond differently to different code, and even within that, the same browser with different versions can respond differently to the same code. So you need to test in multiple browsers. Just because it works in one browser does not guarantee it'll work in all the browsers. You want to test in all the major browsers, Firefox, Chrome, Safari, etc. for production software. For production software and for your final projects, obviously you want your final projects to work on different browsers. You know, you don't want to like go to an employer and say, look at my final project. Oh, by the way, it doesn't work on Safari. You know, you're looking at it on your iPhone. Oh, I'm sorry. You know, so you want to change browsers for testing purposes. Very real world thing to do. Okay, so that's how to change browsers. We talked about how to run it in multiple browsers. Okay, hot reload. Hot reload, if I go ahead and stop, is right here. It's this little grayed out icon. If I go ahead and hit my debugging mode, notice I get this option to hot reload. And it's kind of what it sounds like. I'm going to hot reload on file save. So what you're able to hot reload are things like your HTML, your CSS, and many things in your C#, not all things in your C#. Okay? Like going back to the JavaScript world, when you had environment variables, you could not hot reload environment variables. So not everything, it's the same thing in the C# world, not everything in C# can be hot reloaded, but a lot of things can. Okay? So if I enable hot reload on file save, and let me go into my views of my home view and put a couple exclamation points on the heading. Okay, now if I go, before I click save, okay, obviously no exclamation points, click save, okay, hot reload kind of should do its thing and we get our exclamation points, right? So pretty simple. You know, you can do HTML hot reloaded, you could do CSS, and lots of things in your C#. Okay, it's, you know, it is what it is. If you're trying to hot reload something and it's not working, of course you could just shut it all down and reboot it, and that's what hot reload is. Now, you might have to. You guys have seen this if you've used hot reload. You might have to click this box to always rebuild when updates can't be applied. And so if you're making changes to the C#, obviously you might need to rebuild, which is recompiling your code and getting it ready for running. And so checking this box once and then rebuild and apply changes is typically something you have to do one time. And again, changes to most C# code in controllers, models, and views are cool. It's when you start getting into the C# in your app settings and you're dealing with things like connection strings, right, and program CS. This is C#, and again, middleware and environment variables, a little bit harder time to hot reload some of this stuff. All right, the next tool, of course, when you're testing and you're debugging is the browser developer tools. So F12, if you kind of bring up the page here and you're like, hey, I want my background to be red. Why is my background not red? Well, you're going to hit F12. And just like we learned in the HTML class, you're going to inspect the thing and you're going to look at the HTML and you're going to look at its CSS and you're going to look at all of the CSS that's being applied, and you're going to see that your red background is overridden because it's not a specific rule that you wrote, right? So the rules of specificity aren't being applied, or whatever the reason is. Point is, this is another tool, right? The developer tools, F12 in your browser, All major browsers have developer tools. You've seen these before. You've seen this a lot. And so it's another tool at your disposal to troubleshoot. I remember back in the day, you had to download extensions to get these kinds of things. At one point, only Firefox had the extensions for you to be able to. Every browser you can inspect source code, but not these kinds of tools where you can look at the HTML and the CSS and the JavaScript without some sort of extensions. Okay. And so where we left off, slide 12 here, is looking at an exception. Someone remind me what an exception is. Let's do a little Q&A. What is an exception? What is an exception? Not everyone at once.
You mean beyond like an error?
Okay, so it's a type of error. That's a valid answer. Yeah. Anyone want to elaborate on that? So when it comes to errors, there's logic errors, there's runtime errors, and there's syntax errors. So more specifically, which one is it? Is it a syntax error? It could be caused by a logic error, potentially, but runtime, right? Exceptions are runtime errors. Okay, so more specifically, so good answer, but just a little bit more specific, it's a runtime error. That these errors, I mean, logic errors are like 2 + 2 = 9. The program's still running. You're just getting bad results, right? So exceptions are different. What happens when you hit an exception? As we're looking at it, what happens?
The program stops.
It stops. Exceptions crash the program. Okay, so just going back to what is an exception, this is what we're looking at. We're looking at an exception when you get an error like this, but specifically it's a runtime error that crashes the program. Now, we learned a tool for handling exceptions in C#. How do we handle exceptions? Try catch, right? So if you programmatically don't want this error page to happen, remember your try catch blocks. And remember that, hey, this exception is called a SQL exception. And if you wrap the line of code that causes this exception to occur in a try catch and you catch a SQL exception, that you can prevent this from happening. Okay, but keep in mind, not all softwares need this to happen. Sometimes it's okay for your software to crash. It's not like the website's crashing for everybody, right? When an exception occurs, the web application is crashing for you, but it doesn't crash for anybody else, right? It's just crashing in your browser, okay? So exceptions don't crash it for everybody. It just crashes it for you. You can handle these exceptions with try catches. You just have to know how to handle exceptions. Now, exceptions are errors, and they tell you information. So when it comes to troubleshooting, when it comes to problem solving, the first thing to do is understand the problem. When you and I and everybody else, they come across these error messages like this, you need to understand this error message. Your gut instinct is to close it. Like panic close, right? Well, that doesn't help you understand the problem. Like read this, right? Read this error message. SQL exception, cannot insert null into table name. Column does not allow nulls. Insert fails. Okay, but I'm going to tell you when beginners see a nasty error message like this, the first thing to do is panic and close, right? But no, you need to understand the problem. So it's actually, and I don't know the name of this phenomenon, but there's a phenomenon, or there's a tendency. There's a tendency that as developers, we write code, we tend to think that the code we write is good. And therefore, when something bad happens, we tend to over-gloss it's a problem with my computer, it's a problem with With Visual Studio, it's not the code that I wrote. Okay? That's why, you know, a method of troubleshooting is called, rubber ducky troubleshooting. You guys have heard of this? Have I told you this before? What is rubber ducky troubleshooting? Yeah, you got to have the rubber duck there, and you explain line by line how your code works and why it should work that way.
So many people in our programming humor swear by this.
Yeah, exactly. So, yeah, our programming humor. Sorry to cut you off there, Max. Even when you're writing an English sentence, like, you're not going to read your own words word by word. When you have a mistake, you tend to gloss over your mistake. It's the same tendency in coding. You have a mistake, you need to critically look at your code and explain it to an inanimate object what your code is doing and how it is working. In the event that you get this, I would critically explain my error message to my rubber ducky. Okay? Because you need to understand the problem if you're going to begin to solve it. This screen has a lot of information. Additionally, there are some actual links down here. Stack, query, cookies, header, and routing. You can see here, what is the stack trace? The stack trace is an important programming term you should all know. The stack trace is, hey, we're executing line 1000. Why are we executing line 1000? Well, it was called by line 50, which was, method 1 was called, method 2 was called here, method 3 was called here, and method 3 has line 1000 in it. So the stack trace is the list of methods, kind of your breadcrumb trail through the woods, as far as like why you're at the place that you're at. Like, how did you get here? It's your breadcrumb trail through the woods. Okay? So if you need to understand the call stack, why did this, what line of code is even causing this exception to occur, and how did I get here? How did I get through the woods to execute line 1000? Query parameters, we know what a query string is. Like, what are the variables in our query string? Cookies, dealing with the data stored on the hard drive, dealing with the cookie, dealing with HTTP headers, or dealing with routing information. All of that is available in the browser. There's a lot of information here that can help you understand the problem, because if you're going to solve a problem, you have to understand it. Step 1 of solving a problem is firmly understanding it. So there's a lot of information. Now, you get this page. Notice we're looking at a browser here. You get this page when you start without debugging. Okay, this will crash in the browser. That's called bubbling up. Exceptions will bubble up and crash in the browser. Versus here, this is starting with debugging. This is a different screen. This is called the exception helper. And it's basically the same information. The only new option here, and I've never messed with this, is start a live share session. Like, the idea here is that probably with some premium access, you could get a developer to help you with your code. In the event that you have some like premium membership with Microsoft, you could get a live person to help you write code. But I've never done that, so not really quite sure. Okay, so that's all about exceptions. That's what an exception is. That's how to troubleshoot exceptions. Again, you can handle them with try catches. That will stop this from ever happening. And we will do that. We will handle our exceptions and route you to a generic like 500 server error. Okay, I play a lot of chess.com. I don't know if you guys are into chess, but the game of chess has really exploded in popularity. And because of that, their servers are overwhelmed and their servers are crashing because of the increase in demand, and they don't have enough server power to supply that demand. And so their servers are crashing because there's just, 500 error. And so instead of seeing like some exception helper with the program crashing, they have a generic 500 page. And on that generic 500 page, it's a YouTube video of a chess YouTuber And he explains like, hey, chess is gaining in popularity. Everyone's trying to hit the servers all at once. You know, this is the problem that they're having. So it's like a really useful, exception page. Instead of seeing an ugly message like this, you get a YouTube video with a YouTuber explaining the problem, which I think is pretty awesome. Okay, we talked about breakpoints, removing breakpoints, enabling and disabling breakpoints. We talked about break mode. We talked about the commands to get through the breakpoints. We talked about the windows in break mode. The one thing I didn't talk about is the immediate window. Okay, this is just a command line interface for inspecting your variables the same way you can inspect them in autos and locals and watches. You know, you could say, hey, notice right here. Here's a little question mark. What's my movie name? Oh, it's null. And then at another point, my movie.name is set to Wizard of Oz. And then it's this string. And then what's my movie slug? And, you know, it's just a command line terminal for getting the same information you could get through the GUI. Okay, I don't really use this immediate window much because you can get the information through a GUI. I mean, that's why Windows, the operating system, is so popular. It's because people like GUIs more than command line. So if you can use a GUI, use a GUI. That's my choice. All right, we talked about trace points. I already showed you how to set a trace point. And the output window, how to set a trace point. That is the end of that lecture on troubleshooting. Very, very, very valuable lecture. At least valuable theory, okay, in that lecture. So we will stop the lecture here.